Kapla, everyone. My name is Mr. Field. I am the lead of the Bryan Adams Academy of Engineering, AOE, and I lead robotics coach. And I wanted to put this tutorial together for you guys. If you're interested in doing some 3D printed projects in your classes, we have 3 of these printers right now on campus. They were awarded 100 of them to North Texas schools, and this is an Ender Pro 3 that you could buy here on Amazon for about $250 to get you started. But they are very popular right now, probably the #1 3D printer out there, and they're very capable. And to kind of get them an idea here, the print size is 10 inches by 8.5 by 8.5. So that gives you an idea. And so I'm gonna walk through the whole process. So I'm gonna show you how to use one of the printers we have on campus. So I have one, Mrs. Riggs has one. We'll probably have another one in Mr. Sparks's room. And we actually have another one in the back room, which is a different type of 3D printer. It's a little older. It's actually a little better, much more expensive. So we have the capability. And I'm going to show you the whole process. So this software to do it is available to everyone and is available to students using their G Suite. So if you go to TinkerCad, TinkerCAD, you can log in with your G Suite, and it automatically logs me in. But you can choose to log in with Google, and you should be in there. Actually, it's funny. I was just setting this one up to show you as an example. So I'm going to go here, create a new design in TinkerCAD. So you can use any type of 3D modeling software, but this is set up by Autodesk to be really accessible, especially for like first-time 3D modeling, middle schools, elementary schools. It really gets the user quickly up and running in 3D. And you can see over here at the right, we've got different types of things that we can create. We can create basic shapes, numbers, characters. And then up here, we've got some tools we're going to use. We're going to use export when we get ready to 3D print it. But so let me do an example here, huh? Put a roof down here. So with most 3D modeling, you have these little controls nowadays that allow you to physically just go in there and move and change stuff, including things like the angle here. So what I'm going to do is I thought maybe I'll give you an example. If you ever wanted as a student project or something for your students to give them an award, like Best Student of the Year, or a Tin Man Award for the student with the least amount of heart, maybe we'll make this one a Tin Man Award. So I'll show you the other thing you can do. I'm going to add text here. And in this case, I'm going to rotate that text and change it around a little bit. There we go. I'm going to put it in alignment here. So I'm going to view this from the side so I get that ability to move it as such. And got to be careful. You see I moved it all the way out there. Oops. Oh, by the way, I have a mouse when I'm doing this. So, and you kind of will learn when you get in here that the right mouse button will rotate. So I'm just hitting Control Z to undo that. So I did want the rotated element here, and you'll see why. I think I'm going to try and line this text up. And then move it onto that block like this. And then there we go. So just for fun, I'm kind of creating this like 3-dimensional text that's going to kind of pop out. You can think of this little ground plane here as your printer pad and your 3D printer pad for the 3D printer itself. And then I can change this text to, what do we call that? The Tin Man Award. And you can change certain things there. We can change the color. And I'm going to make it a whole, and you're going to see why here actually in a second, because what I can do is if I select both of these things now, I can group them, and it will go ahead, since I made it a whole, it will go and actually just kind of like cut that out. This is called subtractive modeling. So in 3D modeling, you use a lot of this kind of technique where you add and use other elements to subtract from the existing geometry. And you can see here, it didn't really do a great job of getting all the way in there. So I'm going to go ahead, make this a little bigger, and try and move this again. There we go. Now if I select those two, I can group them. It will cut that into the thing. And so any of these shapes, anything that you can find in here. So neat. I wanted to show this to you. I just learned this. I haven't used TinkerCad a lot because we use Onshape, which is also a software available to the students for free, and SketchUp as well. I've really had a great success this year with SketchUp, and that's also a G Suite logon. It's a real fun, quick application to learn. You can change the environment here to blocks or Legos, which is pretty neat. Okay, so if I was happy with that and say, oh, I love this little award to be able to give to kids and print it, and then what I can do is I'm going to go back out here and it will save it automatically. It'll save this file automatically. Actually, I could have hit export when I was, you could share your models. There's different things that you can do. You can download that. But I'm going to double click it. I'm sorry, I'm not sure why it's not letting me back in here. Let me see. I wonder what I can, here it is. That's fine. I can download this as an STL. That's the file, that's the type of format that most 3D printers are standard at. They're called STL files. And so now I'm going to show the other half of this. So once you've got 3D you like, and you'll never lose, you don't have to save it. It will be back there when you log back in into your TinkerCAD file. But for these Ender Pros, they use the most common software out there is the for the 3D printing is the Ultimaker. And so you can download this, sign up and download this for free. And me, I have it on my computer already. And so I'll bring it up and then you'll see how I import the file and finish off with the actual setting up an actual print. So hopefully, before you move on to this setting, go ahead into TinkerCAD, design something in 3D really quick. You're going to save it and download it as an STL, okay? So once you've done that and saved it, then let's go ahead and come over here to Ultimaker. So there's different qualities that, like the Ender 3 Pro, I set up Ultimaker here by configuring the printer type, and you normally need to do that with 3D printing, tell it what type of printer you're going to. So in this type, go and find the Creality Ender 3 Pro. And then you'll get a virtual space right here for printing. And this little window here will be your kind of like all your tools, and you'll see another window pop up here, and I'll show that to you too, okay? So quality, you can go the best quality it has, and this is a pretty good quality. And so if you need something to function as a piece of hardware, or you need good quality out of it, or low quality, that'll print faster. It's got a bigger bead size, and if the quality isn't that important, so you kind of have to judge based on what you're making there as far as the quality level. So And there's elements, a lot of great elements of, like, say, density right here involved in the way you 3D print, because a really cool option of this type of printer is that you can do infill patterns. So it can be 75% infill or vice versa, 25% infill. And that's going to mean it's 75% air. You can change the shell thickness layers or just keep these as standard as they come in. 3 layers, I think, is pretty good normally for any kind of shell. But then infill over here, we have that set at 75, and that would print with 25% air, with 75% material. Whereas I've had success with structural parts as low as 5% infill. This gyroid pattern's my favorite, but this is interesting. I'll show this to you really quick. And that is when you look at infill patterns and what each one of them does. There's a great website that Kara has put together. I do this as a lesson for my kids, actually, and I really link this to the understanding of how density works. But this website here will walk you through what each of the different infill patterns is, why you would use them, and where you would use different infill patterns. Pretty informative little article here on how to do that. Okay, and then so I'll bring in our model. So let's do that next. So I go to my folder here, and that's where I saved it. I think it's on my desktop. I actually am not sure. So let me take a second here. Yeah, it's this thing. Yep. Okay. There it is. Pops in. This thing, I would print really at only a 5% fill. Let it print quickly, not use much material. I do the gyroid infill because I love it. It's more of an organic infill. It's just happens to be my kind of favorite, but I could easily do also grid or lines for this thing. So there's no structural requirement from it. It defaults here to this build support area. It'll print a little strip all the way around the part just to make sure it's getting good adhesion on the plate when it goes to print. All right, and then when you select the part, you can do different things like move it, move this around. Print orientation is important. We can even make copies. So if I right click on my mouse, I can say select multiple and make 2 and move those around. But I'm just going to go ahead and pretend that I'm going to print this. But actually, I have a robotics part that I do need to print. And what I'll do is kind of set that up right now and show you that here. So, so let me open file. So I have a student here who has a hinge that he's designed for the robot. Now it doesn't print like that. It imported it like that, but that's not a good way to start this print. We need to align that face right there. So I'll show you. If you go over, I think it's here. Let me highlight this again. Oh, there it is. I'm sorry about that. That's the one. You can select what face you want to be face down. And so I just selected that and we'll put that face down. Okay. Before I go to the printer side, what I'll need to do is say, all right, and we're going to slice this. And so this is where it writes the code for every layer. It's a built up, layer of. It's like the way to think of a FDM like 3D printer is just like a hot glue gun on a 3D axis, and it lays down layer by layer. And there's a lot of this tech that goes into that, but you can learn that as you go for just learning. Just keep it simple. Okay, so I can preview these layers, and that's when I always do that, just to make sure it looks like what I'm intending. So let me put this, again, the right mouse button will spin around so you can see it. And then you can pull this thing down and you'll see that the layer is exposed. And you can see now that I chose that only 5% infill. So most of that part in the middle is kind of, you can see where the walls are and see where it's empty there. It's, you know, it doesn't print solid. And there's this little skirt that it puts around it because it wants to make, if you have, it'll print this first, and then if you notice if it's not sticking well to the base, then you got a problem with your print. You need to restart. All right, now